All right, guys, this is your podcast for electromagnetism. Again, you can use the PowerPoint and take your notes that way, or you can listen to me give you the notes as we would normally do in class. So, this is the lecture on electromagnetism, which is going to include your electromagnets, your motors, and your generators. So far, we've been talking about electricity, magnets as separate entities. Today, though, we're going to combine the two and we're going to create our electromagnetism. So, our electromagnetism is essentially our relationship between electricity and magnetism. In other words, each one of these can induce or make the other one happen. So, when electric current flows through a wire, we can actually create a magnetic field around that wire. That direction of the magnetic field depends on the direction of your electric current. If you reverse your electric current, you can change your magnetic flow. You can also induce magnetism, or you can induce electricity using magnetism as well. So we're going to be going back and forth between the two. The first device we're going to create is called an electromagnet. An electromagnet is created by electricity going through a coil of wire, which is called a solenoid, very special term, write that down. It's been wrapped around an iron core. Now, this core could be iron, nickel, or cobalt, but that's it. Those are the only three metals we can use inside of our electromagnet because they're ferromagnetic, meaning they're the only metals that can be turned into a magnet. Any other metal will not work. You have to use a metal, iron, cobalt, or nickel, that can be turned into a magnet called ferromagnetic. Now, here's a diagram of our very basic electromagnet. You see we have a wire that's coiled around an iron core, in this case an iron nail, and attached to a battery source. This coil of wire is called the solenoid, and that's your coil of wire that carries that electric charge. The coil of wire actually produces a bigger magnetic field than just a straight wire, so that's why we coil it around. Now, electromagnets are used from anywhere between small household objects to very large objects. Some examples of small electromagnets would be something in your hairdryer, a speaker, your doorbell. But large electromagnets you would see in the junkyard, where the junkyard crane picks up the car and moves it to a different area. Recycling centers use these. And then the maglev trains that uses levitation in Europe to be able to reduce the friction between the tracks. They also use an electromagnet. The important thing about an electromagnet is you can turn it off. Once you're done using the magnetism, you just turn off the current and the magnetism completely stops working. So the use for electromagnets is a lot better than just using regular magnets because you cannot turn magnets on and off. Whereas electromagnets, you can easily turn on and off to where you want to drop something that's magnetic and you turn off the current and there's no longer magnetism. Now, there are ways to make electromagnets stronger, and you're going to be doing this tomorrow. The first way is you want to increase the number of your loops in your solenoid. The tighter and more loops that you have in your solenoid, the stronger your magnetic field is going to be. That's because your electric current is going to work together to create a bigger magnetic field. You also are wanting to increase your electric current. Just like we said with our current electricity, if you increase your electric current, your voltage, then you're going to increase your current, and therefore you're going to make a stronger electromagnet. Stronger current, stronger magnetism. The last way to increase your electromagnet is increasing your iron core. Using bigger, more ferromagnetic iron cores are going to make it stronger. Using something that's made out of iron, cobalt, or nickel will make it a lot stronger than using something that is not one of those materials because they can't be made into a magnet. So tomorrow you will build a simple electromagnet and you will be introduced into figuring out what makes them stronger, and you will also be figuring out a challenge to pick up the most paper clips. So the way you make one is you take a battery, you're going to take a wire, and you're going to coil it around what we have as iron nails. Once you coil it around iron nails, you're going to attach it to your battery, one to the positive, one to the negative, so you flow from the minus to the plus, and bam, your iron core becomes a magnet. So then you can use that to pick up paper clips to see how strong your electromagnet is. Now, the other use that we use for electromagnets is we have something called motors and generators. And motors and generators both use an electromagnet in conjunction with a permanent magnet. An electric motor is a device that changes electrical energy into mechanical energy or motion. So as you see from our picture, we have a battery connected into a coil that rotates between a permanent magnet. As this rotates through the permanent magnet, it's creating motion as it's hitting that permanent magnet with the electric current. So the direction of our motor is going to depend on the direction of our current. You reverse the current or you reverse the magnets, you're also going to reverse your motor's direction. So electric motors, again, make motion. So motors make motion. You take electrical energy and turn it into a motor, a mechanical energy. So we use motors for a lot of things. Small things, you have one in your computer, vacuum cleaners, washing machines. We also use them in Ferris wheels, car engines, merry-go-rounds, pool pumps, really anything that has a fan or a turbine that spins, that's going to be an electric motor. It uses electricity, electrical energy, and it turns it into mechanical energy or motion. A generator, on the other hand, is the opposite of a motor. A generator uses magnetic induction to change mechanical energy or motion into electrical energy. In other words, electric generators generate electricity. They still use the use of a permanent magnet and electromagnet to generate, in this time, current. So you're using the electromagnet and the permanent magnet by cranking a crank and spinning a wire through a permanent magnet to make the electrons flow through the wire. In this case, you are generating, using a hand crank, mechanical energy or motion, into electricity to make something light up. Here's a hint. If the pictures have a light bulb with a hand crank, you're talking about a generator. Generators generate electricity, mechanical to electrical. If you're talking about a motor, you have something that is spinning, moving. That's electrical to mechanical. Be careful, they are confusing because they are direct opposites of each other. If you have any questions, write them down. I'll be happy to answer them tomorrow when I return. Otherwise, head now to Teams to try your electromagnet practice. I'll see you tomorrow.